Hello, welcome back. Now we want to give a summary of our previous lesson on acid, bases, and salt. This is a summary of the previous lesson. Acids, bases, and salt. You should be aware that from your previous knowledge and the last class we had, you should be able to define what an acid is and what a base is and what are salts. You should be able to give the different characteristics of acids in terms of their reactivity with metals, with alkali or bases, with carbonates. You should be able to give the characteristics of acid and bases in terms of their hydrogen and their hydrogen ion concentration and their OH ion concentration in water. You should be able to use that knowledge in trying to describe the pH of an acid and the base and their strength, weak and strong acid, as well as weak and strong bases. In that same order, you should be able to use how you can use a universal indicator indicators solution or papers or pH papers to differentiate between an acid and bases or alkali. Firstly, you should understand what is an acid. There are two types of theory: the Arrhenius theory of acid and the Bronsted-Lowry theory of acids. The Arrhenius theory of acid defines an acid to be a substance which ionizes in water to give hydrogen ion as the only ion. Whereas the Bronsted-Lowry theory defines an acid as a proton donor. When an acid in solution ionizes, it gives out or it donates an electron, it donates a proton. That is the only proton in solution, a proton which is positively charged in solution. We can now say that a proton, an acid, is a proton donor. Or an acid is a substance which ionizes in water to give hydrogen ion as the only ion, as the only positive ion. Secondly, we can define a base as a substance which ionizes in water to give hydroxide ion. It ionizes in water to give hydroxide ion. Bronsted-Lowry theory, on the other hand, defines an acid to be a proton acceptor. So, as we say an acid is a proton donor, we said a proton and a base is a proton acceptor. Acids have different characteristics. Acids, as you know, acids, their characteristics vary. 1. Acid have a pH less than 7. Acid will neutralize bases. Acid form hydrogen ion in solution. Strong acids are very corrosive. Acids are good conductor of electricity. acids have a sour taste. In nature, we have many acids. We have many things in nature that that contain acid. Citrus plants like a lemon, lime, all of them they contain acid in them because they are sour in taste. Acids have a high concentration of hydrogen ion in solution. Because of the high hydrogen ion in solution, when they ionize, the solution become the solution become too acidic. In this case, we say the higher the concentration of hydrogen ion concentration, the higher the concentration of hydrogen ions in solution, the stronger the acid. And the stronger the acid, the lower the pH. Once more, the stronger the higher the concentration of the hydrogen ion in a solution, the stronger the acid. The stronger the acid, the lower the pH. Conversely, on bases, we can say bases, they have a bitter taste. Bases, they have a bitter taste. Bases, when they dissolve in water, they form alkali. Strong alkali are very corrosive. Bases or alkali, when they react with acid, they form salt and water. In terms of universal indicator paper, alkali will turn red litmus paper blue. Unlike in acid, the acid will turn a blue litmus paper red. Bases are bitter in taste. They are soapy, that is slippery in nature, and can even produce foam. A good example of substances in nature that contain that have a basic content we call is like aloe vera plant. It is bitter in taste, soapy in nature. Acids, as you know, in their reaction, acids they are weak and they are also strong acids. How do we know? It all depends. It all depends on their level of ionization. Based on the level of ionization, we can determine whether the acid is a strong acid or the acid is a weak acid. We say strong acids will ionize. Strong acid will ionize completely. Strong acid will ionize completely. That is, they will dissociate. Strong acid will dissociate or will ionize completely, releasing all the hydrogen ions in solution. That is why all strong acid will react vigorously with metals, because the solution contains a high concentration of the hydrogen ion. Meanwhile, weak acids, they ionize partially. They dissociate partially, releasing just a few hydrogen ion concentration in solution. Meanwhile, part of the hydrogen are still attached to the compound. An example of a strong acid is hydrochloric acid, HCl, which ionizes fully or ionizes completely to give hydrogen ion and a chloride ion. The solution has a high concentration of hydrogen ion because all the hydrogen ion have been released from the acid into the solution. Hence, the solution will have a very low pH. Ethanoic acid, which is otherwise called vinegar. Ethanoic acid, which is otherwise called vinegar, is a weak acid. Why do I say it is a weak acid? It ionizes partially. It ionizes partially into the ethanoate and the hydrogen ion. That is, only a few of the hydrogen ions are released into the solution. Most of the hydrogen are still attached to the compound. In that case, because there are few hydrogen ion concentration in solution, we call it a weak acid. And because it is a weak acid, it will react slowly with metals. It will react slowly with metals, releasing hydrogen. Then bases. They are also strong and weak bases. Strong bases, on the other hand, will ionize completely in solution, releasing the OH ion. The OH ion, or the hydroxide ion concentration in solution, is the one that determines the alkalinity of the solution. It determines how strong the solution is. Lastly, salts. We are told salts are formed. These are compounds that are formed when the hydrogen ions in an acid are replaced by metal ion or by an ammonium ion. For example, we have HCl. If hydrochloric acid reacts with sodium hydroxide, the hydrogen in the hydrochloric acid is replaced by the sodium metal, giving us the sodium chloride. That is the salt that is formed. If the hydrogen is replaced, by an ammonium salt, we call it an ammonium. By an ammonium ion, we call it an ammonium chloride, and this is a salt. We call them ammonium salts. In nitric acid, if the hydrogen is replaced by potassium, we will have potassium nitrate. In sulfuric acid, if the hydrogen is replaced by a calcium, we will have calcium sulfate. So summarizingly, salts are compounds that are formed when hydrogen ion in an acid are replaced by a metal ion or by an ammonium ions. Where these are replaced by an ammonium ion, we call them ammonium salts. Other ones are salts of metal. There are three major types of salt: the chloride salts, nitrate salts, and nitrate salt and sulfate salts, including ammonium salt. So the strength of the pH, the strength of an acid is determined. The strength of an acid is determined based on the concentration of the hydrogen ion in solution. Remember, all acids are hydrogen-containing compounds. Every acid has a hydrogen, has one or more hydrogen attached to it. For example, HCl has one hydrogen, nitric acid has one hydrogen, sulfuric acid has two hydrogen, and many others. So an acid is a hydrogen-containing compound, and it expresses its strength based on the hydrogen ion concentration that it releases into the concentration when it ionizes. The pH scale runs from 0 to 14. The pH scale runs from 0 to 14. The pH is a measure of the relative acidity, that is how acidic the solution is, or the relative alkalinity, or how alkalinic the solution is. So the pH scale is just a measure of the acidity or the alkalinity of a substance. We will now go into trying to see how the pH scale of acids and the bases can be determined using our universal indicator papers. An example of a universal indicator paper is the litmus paper. In an acidic medium, the acid will turn the blue litmus paper red. It will turn the blue litmus paper red. And in an alkaline medium, the red litmus paper will be turned blue by an alkaline or by a base. Red litmus paper with a drop of a base will turn it into a blue solution, while a blue litmus paper with a drop of an acid will turn it red, as observed in this photograph. There are different types of strong acids, as we said. There are different types of acids. Acids have different reactivity, as you know. Acids will react with metals. When acids react with metals, they will give salt and hydrogen. As I told you, a salt is a compound that is formed when the hydrogen in the acid is replaced by the metal. Take for instance here, in the reaction with magnesium ribbon reacting with sulfuric acid, the hydrogen in the sulfuric acid is replaced by the magnesium, forming the salt, and hydrogen is being released. So acids are compound formed when hydrogen in the acid is replaced by a metal. In other words, we say the acid provides the non-metal ion, while the metal or the base will provide the metal itself, the metal ion. Acid provides the non-metal ion, while the alkali or the base will provide the metal ion, and that one forms the salt. When acid will react with bases, when acid react with bases, there are some bases, we call them insoluble bases, like copper oxide. When they react with an acid, a sulfate is being formed. The copper sulfate is formed. These are insoluble bases. I mean, salts. So insoluble salts that are being formed. This is a neutralization reaction, because when an acid reacts with a base, when an acid reacts with an alkali, a neutralization reaction occurs as a result of the formation of water and salt. Thirdly, acid will also react with carbonates. Acid reacts with carbonates. You will see there will be an effervescence. Effervescence is being produced. Bubbles of gases are being released during the chemical reaction. In that case, when an acid reacts with a carbonate, a salt is being formed. As we said, the metal replaces the hydrogen ion in the acid. So now a salt of calcium chloride is being formed, water is being formed, and carbon dioxide is being released. And this is measured. They can also be measured in the laboratory using a gas syringe, will give us the volume in cm cube of the gas that will be released. It can also be tested in the laboratory using lime water. If it turns lime water milky, it shows carbon dioxide is a product of the reaction. There are many other reactions of acids. There are many other reactions of acid that you see. But basically, the acid undergo three types of reaction. They react with metals, releasing salt and hydrogen. They react with alkali, releasing salt and water. They react with a carbonate, releasing salt, carbon dioxide, and water. There are many other reactions of acid that will be following in the near as time goes. Remember, acids have different. Remember, there are many types of oxides that are being formed: acidic oxides, basic oxide, amphoteric oxide, and neutral oxides. As time goes, we'll be discussing about oxides of metals, oxides of metal, which are the basic oxides, oxides of non-metals, which are acidic oxides, amphoteric oxides, that's oxide that can act both as a base and acids, and we'll also be discussing about neutral oxides. So as we move forward, I want you to go into some to see how this can be applied. What we are studying can be applied. today. Let me share my screen so that you'll be able to see. Watch on. In this exercise, a recap of what we have just said. What are acids? Acids contain a positive hydrogen ion, which is bonded to a negative anion. And the general formula for acid is Ha. Acids ionizes in water to produce hydrogen ion. Acid ionizes in water to produce hydrogen ion. Secondly, in examining the strength of an acid, we can say acid can be strong or can be weak depending on how much, depending on the concentration of hydrogen ion they release in solution. And we said strong acid ionize completely, releasing all the hydrogen ions in a solution. Weak acids like let me say vinegar, ethanoic acid, will ionize partially. For example, HCl will ionize fully, but ethanoic acid like vinegar will not ionize fully. Why we say it ionizes partially is because when the acid ionizes, only a few of the hydrogen ions are released into the solution. More of the hydrogen are still attached to the compound. So only a few of the hydrogen are left or are exposed for reaction. In that case, the concentration of the hydrogen in solution is less. Because of the low concentration of hydrogen in a solution, the acid is weak. Because the acid is weak, it has a higher pH. Unlike a strong acid, it ionizes fully, releasing all the hydrogen ion in solution. Because of the high concentration of hydrogen ion in solution, it will react very fast. It will react very fast. It is a strong acid, and because it is a strong acid, it will have a low pH. Let's go further again to see how we can identify strong and weak acids. Strong and weak acids. In this occasion, you will see that there are different types of acids. There are different types of acids depending on the concentration. The hydrogen ion concentration in solution will determine the acid. Therefore, the strength of the acid. Therefore, we say the pH. The pH is a measure of the concentration of hydrogen ion in solution. In a neutral solution, we can say a neutral solution is 7. In that case, the concentration of hydrogen ion in solution are equal to the concentration of the OH or the hydroxide ion in solution. That is a neutral solution. Acids are good conductor of electricity, but weak acids do not conduct electricity very well. Then, in trying to look at the alkalinity, the pHk also, as I said, the pHk is a measure of the alkalinity. That is how alkalinic the solution is, or the acidity, or how acidic the solution is. And it will all depend on the OH ion concentration, or on the hydroxide, or on the hydrogen ion concentration. The higher the hydrogen ion concentration, the stronger the acid. The stronger the acid, the lower the pH. In other words, the lower the hydrogen ion concentration, the weaker the acid. The weaker the acid, the higher the pH. Thank you very much. In our subsequent classes, we will be having oxides, acidic, basic, and neutral oxides. Thank you for listening. Have a nice day. Bye-bye.